everybody. This is offshore petroleum engineering webinar. Um, and I'd like to welcome the University of Alberta, Cape Breton University, and Memorial University of Newfoundland to the event. I'd like to acknowledge Mohammed Azam in U of A for really taking the initiative to organize this event. I had met Mohammed in the last year up in Calgary, an SPE event. So, and we talked about doing this, and he followed up on it and made it possible. So, appreciate that, Mohammed. Thank you very much. Also, Alka Dash at Memorial University. She's head of the student chapter there for organizing that, and Sean McNeil, Cape Breton University. So. My name is Rod Gibbons. I'll be your speaker tonight. Again, appreciate everyone's time this evening. Yeah, it's in the evening everywhere across Canada now, so appreciate your time. There is a Q&A board along here. I'll use that as to get questions in as we go. So please feel free to type it in. Agenda. Well, I appreciate your time, and so I want to make sure that we all get good value out of this. Just on the housekeeping points, my opinions are my own, and I'm not speaking on behalf of any associated companies or organizations. I'm going to tell you what I think, and again, it's not for the companies that I work with or partner with. I'm not representing them. I'm just representing myself. This presentation webinar will be recorded and published. So just so you're aware of that. Place questions in the Q&A box for this webinar. As we go through, just put them in there. If I pick them up at the time, I'll pick them up. Otherwise, we'll get them at the end. If we don't get them at the end, next week, we are having, we call it office hours, on Wednesday evening. I think it's around 5:30 Alberta time, 9 o'clock in Newfoundland, 8:30 in Cape Breton. And so this QR code is, if you scan this, it'll bring you to a link to register for that. And that's where we'll dig into these questions a bit deeper and just talk more in depth on some of the topics that we got a lot to cover in an hour tonight. So yeah, next week we'll sorry, excuse me. Next week we'll go into a bit of a deeper dive on that. So yeah, scan this now. Hopefully it works. And yeah, otherwise I'll send you a link at the end of the session. What we're going to talk about tonight. First, I'd like to talk about is the oil industry. It equals opportunity, and I want to tell you about my thoughts on that. And then a bit on petroleum engineering activities, what they are and where they are. And then we talk about some offshore technologies, platforms, drilling rigs, Christmas trees, similarities to onshore and differences. Do a bit on Canada's offshore, because I think most of us are in Canada tonight, so that's relevant. And then just sum it up with some conclusions. When it comes to offshore petroleum engineering, what I'd like to say is you can do it. You can do it. Most of the people in this webinar are engineering students. A few years ago, you probably didn't think that you would be able to do engineering, and now you're in school doing it. I know when you get on a work term, and or a summer job, and you're working in a small shop somewhere, it doesn't feel like engineering, but it's all stepping stones. And so um, everybody listening to this, offshore petroleum engineering, you're able to do it. You can do it. There's no reason why to not do it. And you can do it anywhere. And I mean literally anywhere. Um, I'm sure there's people from Alberta, from Newfoundland, from Nova Scotia, and also from international locations. You can do it anywhere. It's worldwide. The other thing I'd like to say about offshore petroleum engineering, offshore industry, is all types of people are needed. And the picture I have is, this big pieces of metal, and it all looks really rough and tough and that sort of stuff. And if you like being outdoors, you like field work, yes, there's a place in the oil industry and in petroleum engineering for you. But also, if you like research, if you like computers, if you like data science, there's also a place for you in the offshore industry. I spent, I think, the last probably 4 months working with a group out of Tennessee on microbial DNA samples. So we had taken fluid samples and actually did DNA test kits on them, which we had to do offshore because we couldn't get them to the lab in time with refrigeration based on our location. That's been a 4-month project. It is really so. I'm not a microbial scientist. I'm a mechanical engineer, but that's the sort of things that you can get into in offshore petroleum engineering. So there's no limit. It takes all types. And I guess the other thing I'd like to say is that onshore translates directly to offshore. The stuff that you learn on work terms, on working onshore, a lot of it is really transferable to offshore. Just looking. Did you see a question coming in here? International grad student, your experience, which technical and interdisciplinary skills are most valuable for engineers who want to build a long-term career in the field? Which technical and interdisciplinary skills are most valuable for engineers? Well, I would actually say the most, and so that's an excellent question. So I would say the most valuable skill that you can learn is actually, it's not really a technical hard skill. It's actually a soft skill. And it is, well, there's two. One, learning how to think logically about a problem or an opportunity, because that, if you can do that, then you can transfer that to any field. And number two, being able to work as a team, because some of the issues and some of the problems that you have to work in petroleum engineering and offshore petroleum engineering it's very difficult for one person to solve it. But if you have a team working on it, you can really get a lot of answers. So I would say, if I were to pick one thing to specialize in, it would actually be two things. It would be teamwork and the ability to think logically. But excellent question. Thank you. As I said, based on my perspective. So my unique perspective. So as I said, my name is Rod Gibbons. I'm a mechanical engineer by degree, and I've worked as a petroleum engineer by designation for the last about 30 years. I'm a graduate of Memorial University of Newfoundland, Graduated in 1997. I started working in the oil industry in, say, 94, 95 on work terms. Um, and, and I had the benefit at that time. The Hibernia platform which is the first platform in Newfoundland, was under construction and commissioning. And I did get a work term there, a couple of work terms with Mobil Oil. And that's why I feel passionately about saying you're able to do this, because without that experience, I wouldn't have thought I was able to do it. But because I had the opportunity to go and work and meet with the people and see and really enjoy it, that got me very excited about the oil industry. I then ended up, I got offered a job by Chevron as a production engineer in Slave Lake, Alberta. And I didn't know what a production engineer was, and I didn't know where Slave Lake was. But I said, yeah, that sounds good. So, and for those of you who don't know, the people in Alberta, I'm sure know, but Slave Lake is about 2 hours north of Edmonton. So it's pretty far north by my standards. So I was there for a few years. And what I ended up doing was service rig supervision, service rig coordination. I had a background in mechanical engineering, so rod pumps, ESPs, that sort of stuff was really where I started. And then a few years in, the price of oil, like in the late 90s, it went to about $10 a barrel, and so I said, okay, well, I don't know what it normally costs. So, but that was low, so that you know. And so about 60% of the people where I worked got laid off. And my boss came to me and said, well, I got good news for you. Is well, you're now you were in the field doing service rigs and pumps. Now you're the production engineer. And I said, oh, okay, well, that's good news. How much more do I get paid? He said, well, nothing, but you have a job. So I said, okay, that's good. Worked there for 4 or 5 years. Then moved to Calgary and managed a drilling program in Manitoba. So Chevron had a field in southwest Manitoba. And I'm just going to back up here. I see this question. I mentioned teamwork. Will companies be willing to allow students to join offshore easily? I heard it is very hard for students to go offshore. Yeah, I think I can come back on that later, but it is difficult as a work term student to work offshore because there's a lot of safety training that needs to be done in order to enable that. So there's probably a month of training for safety training for going offshore. So for a work term of 4 to 6 months, that's a lot of training that you get. So it is difficult to go offshore at work, but I mean, you can work in the office, say easily. I mean, lots of companies, offshore companies, take students. However, I feel that there's a lot of value in working onshore initially, and because you get a lot more, because offshore is much more expensive than onshore, and it takes a lot more logistics to move things around. There's a larger team that's got to make those decisions. Whereas onshore, you get a lot of running room. You get a lot more running room to try new things and so yeah, there's a lot more. It's not a bad place to start at all onshore as a student. It's better to be active and doing lots of things than working in a big high profile field where you do very little. My opinion. Anyway, so I did Manitoba and then got transferred to Chevron USA in Louisiana. Worked in the Gulf of Mexico for a few years. Again, also very, very interesting work. Now I'm really into the offshore side. after a few years onshore, or about 7 years onshore. And then changed companies and went to Vermilion Energy, which is a little bit larger company now. It's a medium-sized company in Alberta. At the time, it was like a startup. So went to the Netherlands in Europe, and for joining Vermilion Energy, and it was a real startup. Like, I had to go buy the paper for the printer, that sort of thing. So, and was there for a few years. Did some. That was offshore and onshore, mostly gas. Then went to work, transferred to Australia, in Perth, Australia, Western Australia. That was for Vermilion Oil and Gas Australia, and managed their first offshore drilling program down there. And was down there for 4, 5, 6 years, something like that. Then left there, went to Newfoundland as started my own engineering company. Went as a consultant with Husky and Suncor on subsea work there for a few years. Then went back to the Netherlands again as a consultant, doing engineering work for Vermilion Energy and Shell. And then started my own engineering and equipment company, Ballycatter, with my wife, and we did that from Amsterdam, and then during COVID time we were in British Columbia because it was COVID, and then in Alberta, and now working in Newfoundland for as a director of Ballycatter, and also a specialist production engineer for Suncor Energy. And so that's my perspective. So sorry, that's a long sort of story, but basically worked in a lot of places, lived in a lot of places, all the while seeing the similarities and between onshore and offshore, and different countries, different regulations, and like I say, and being a working engineer and manager and owner. And I'm here to tell you a message, which is, well, first thing when you want to talk about something is how big is the opportunity. That's always what you're going to look at when you're going to spend your money or your time, and your time is your most valuable thing. So how big is the opportunity we're talking about? And I'm talking about petroleum engineering in oil and gas. Well, so what I did was kind of very similar to what I guess a lot of people do, is I Googled it in AI mode. And I did countries with no oil and gas industry, because I know that there's a lot. I know there's a lot of oil and gas in the world. So I don't want the same ranking, Venezuela, Russia, Canada, America. I said, okay, where can you not do this? Where is there no oil and gas industry? So then I got the answer. Many countries lack countries with no proven oil reserves. So I got the number of countries back. So I put that into a map. And so how big is the opportunity? So green, there's an oil industry. Red, according to this, there's no oil industry. So that's a lot of the world. But when I looked at it, I was like, Ireland's on here. Wait a second. I worked for a company that had subsea gas wells and a huge gas plant onshore Ireland. So I don't think that's exactly, that shouldn't be red. And then I said, I remember the Swedish company. And to be honest, I don't know if they're exploring in Sweden or somewhere else. So, okay, we can make that one yellow. But I did work with some people from Addicts Petroleum, a couple of people. Actually, one of them was my boss for a while. And And I knew they lived in Geneva, in Switzerland. So that's also not red. And then I said, okay, I don't know if I trust this list. I better dig into it a little bit more. Singapore was on the list here. Well, I've been to Singapore for oil and gas equipment. And then so these are searches that I did specifically for their industry. So yeah, Singapore is 78th in the world for oil and gas. So it's not a big industry, but they have a huge shipyard and a huge manufacturing for oil and gas. And then Tanzania is also on this list over here, one of these. So, and I said, oh, I know it. I work with a drilling manager. They were drilling for helium in Tanzania. I said, I wonder if they got anything there in oil and gas. And actually, this is the Tanzania oil protectorate, something like that, oil and gas protectorate. So, so anyway, I kind of got tired of playing this game because I was like, okay, well, this is not a good slide. So then I said, I'm gonna change direction here, and I'm just gonna take some pictures out of my photo album. How big is the opportunity? You know, we got the international students here tonight. How big is it? So, so yeah, here's some pictures that I took, and or me or my wife took, and I said I'm gonna and I'm gonna start down here, and this one I'll give a hint. This one is in the U.S. and I have to thank my wife for taking this picture. She said we could go to an oil field for vacation, and I said, "Oh, that's pretty good. That sounds like a pretty good deal." But then I found out where it was, which is in Beverly Hills, USA. So we did do shopping and that sort of stuff there. So, but Beverly Hills, Los Angeles is full of pump jacks. It's full of there's offshore islands there, and they're all disguised. They're all, you know, some have fake buildings around them and that sort of stuff. But yeah, Beverly Hills is a big oil field. This one is fairly easy. This one's Canada. I figured I'd put that one in there. And this is the East Coast, of course. And I really like this picture because the water is flat, and that doesn't happen very often. This one here, this is the Netherlands. So I worked out of Amsterdam for almost 10 years, and so this is activities actually in the North Sea from the Netherlands. This was a bit of a good one. I got my wife back here. I said, "Hey, do you want to go to Rome for vacation?" She said, "Yeah, sure." So I said, "Aha, here's some offshore platforms we can look at." So that's in Italy. Down here, this is a land-based rig in New Zealand. And then this rig here, this is taken from a platform looking at a jackup rig coming in. That's in Australia. And this is a pretty unique picture here. This is, and when we're talking offshore and onshore, it's not typical that in an offshore setting like this, you would have a platform with a pump jack on it. I've seen them in a few places, in Manitoba and the Red River, where it sort of floods every year. Slave Lake up in the Muskeg, there's this sort of thing. Louisiana in the Bayou, they've got some of this sort of stuff. But this is actually in France, and so it's about a half hour south of Bordeaux, France. There's a large oil field down there, and this is actually a vacation place, and there's actually pump jacks and oil wells out in the middle of the lake. So my conclusion is on this is, how big is the opportunity? You can do this anywhere in the world, and yeah, and countries you never even think that would have a oil and gas industry. I would say they all do, except maybe Paraguay, Uruguay, and Panama. There's a few, but so they don't all, I guess. But you know what I mean. Like, very surprising places have oil and gas. Petroleum engineering activities. As a petroleum engineer, what kind of things do we get into? Before I go to that, just check the Q&A. Given complexity of offshore petroleum operations, which supporting subsectors are currently the most important for maintaining safe and reliable offshore activities? Not sure what you mean by subsectors, but I would, well, I'll get into this, but I do know that I do quite a bit of work in corrosion and equipment certification and equipment supply. Those are quite important for safety, as well as well integrity. Yeah. So, and I would have to say there's a whole team approach to safety, but we can get into that maybe. If you have some ideas, I'd like to hear some more sort of sectors you'd like to discuss. Petroleum engineering activities. So what's petroleum include? Drilling, reservoir, completions, production, process, commissioning. I left out construction, but construction, materials and corrosion, data science, asset management, etc. When you look at asset management, here, this is a geologic model of a reservoir and some well plans. This is petroleum engineering. We're planning where to put these wells. Asset management, where to put these platforms. What's the best, most economic way to develop a resource? Detailed design. This is a deck extent. This is actually, this design was actually installed in the field. So you can do everything from CAD and 3D design, and then to actually going out and getting it installed and seeing the how it works. Then operations support. One of the key things that as petroleum engineers we need to do is support the people in the field. And again, when we talk safety, making sure they can do their work safely and get home every day. So whether it's well servicing or drilling operations, inspections and logistics, or process control and making sure all these plants and processes all run smooth. We're involved in all of those things. And I put this picture in the middle because I think this is the most the key for me is this is a bunch of engineers working on a problem together. And these are different companies. There's a student, you know, we're trying to work together to get the right answers, to get a better answer, to get a better design. That's what petroleum engineering is. And the skills learned onshore can be applied offshore. Absolutely, yeah, 100%. SPE, as I mentioned, Mohammed, we met at an SPE event and we set up this webinar. So, and I just have one SPE slide in here. And so Mohammed is representing the University of Alberta student chapter. And I'm in the Atlantic Canada region section. So we have different regional sections across Canada, US, across the world. Geographically, that's how our membership comes together. But we also have a thing called technical sections. And that's where different technical disciplines come together to discuss technical issues, to write papers, to debate. And so like some of the current technical sections, artificial lift, asset management, carbon capture and storage, critical minerals, data science, drilling, flow assurance, geothermal, human factors, which is around human engineering and safety, hydrogen, reservoir management, offshore completions. So I'm also on the board of the offshore completions technical section. Every month we do a webinar about different sorts of offshore completions that are happening around the world, and sharing ideas and trying to share solutions. Robotics and autonomous systems. Uh, for the past 2 years, I've been on the board of robotics and autonomous systems. So that's drones, ROVs, and crawlers, like land-based systems. So, yeah, petroleum engineers are busy with robotics, well integrity, well bore positioning, and you see down here. This is from SPE's website. Establishing a technical section. So, if what you are doing is not covered by one of these technical sections, you can start a technical section. Like it's encouraged, because what petroleum engineers do is so varied. Uh, it's always growing. So um, so again, we need all kinds of different types of people as petroleum engineers, because there's different things to do. Just check the just checking the questions. We'll keep those questions coming in, because I want to get through I've been talking too much, but I'll get to the next section and keep the questions coming here. I really like it. Offshore platforms. We're going to go into the differences and similarities between onshore and offshore. And expert say, if being a female engineer, which section you would suggest to join in the oil and gas domain? I would say, as a female engineer, I'll give you the same advice as a male engineer: what you find interesting. And as an example, I would say, I hope, I'm going to say I know, but I hope. So my wife is very active in the oil industry. She's actually up for SPE award in asset management. So I hope she's on the line. And my daughter is also in the oil industry. So and I hope she's also tuned in as well. But yeah. So being a female engineer, I think that's those days are gone. That in the old days there was a bias. Now it's I would say, in the places I've worked, it's no longer an issue, which is Canada, US, Australia, Europe, which includes Netherlands, UK, Norway, France, Germany. There's you can whatever you're interested in. Yeah, it doesn't matter. And I mean, it used to be that offshore crews were male, and there was no female facilities. That's no longer that's not even a thing anymore. So there's I didn't get a picture of offshore accommodations here, but lots of times it's shared bunks, like two bunks and a shared room for the time that you're out there. They will have female male separate, like, rooms, but it's 100% inclusive. Yeah, and it's needed, and not because it needs to be female. It's the diversity of thought, the different ideas. That's what gives the value for going into different sectors. So now into offshore but really good questions, and I want to hear more about it. Happy to talk a lot more about it in office hours next Wednesday. Some different types of offshore platforms. So we have land and offshore rig onshore. We'll have some pictures of those coming up. And then we get into a jacketed steel jacketed piled platform and jack-up rig. And so you can see it's relatively shallow water depth, say down to 100 meters, 300 feet, something like that. Then as water depth gets deeper, you get into a semi-submersible drilling rig and an FPSO, floating production, storage, and offtake vessel with subsea wells. And again, really, it's around water depth and some mid-ocean conditions. And then when you get into deep water, you get tension leg platforms, a spar. So these are floating and they're held in tension to great depths, and then also drill ships for drilling, and also the FPSOs, floating production, storage, and offtake. And we'll just step through these. So when we're talking offshore production platform, to what is it? What's the land? I call it land equivalent. But if you're driving around, going from Edmonton to Red Deer, or you're driving around Alberta, what do you see? It's an oil battery. So it's processing oil. It's a gas plant. It's handling gas. It's oil storage. It's wells. And it's a camp, a drilling camp or a production camp. So this is what an offshore production platform really is. It doesn't look anything like this because it's in a totally different environment, but this is what it does. And so the first offshore platforms were first and still in use, steel jacketed. So this is all like structural steel, and it's pile driven into the seabed, and then with a topsides. So this would be the substructure. This is the topsides, and so this is so you can see here in this platform. See, it's this one is really small, but that's a steel jacketed platform. You see a lot of them there's a lot of them in the Gulf of Mexico and a lot of them in the North Sea. Well, more in the Gulf of Mexico. So, in that sort of continental shelf sort of area, you get a lot of steel jacketed structures. And we'll come back to, and so we'll come back. There's a few other things that we'll talk about on these ones later on. This is just offshore Louisiana. One of the things that you'll notice is, so here, this drilling derrick, and we're going to talk about that later. You see these drilling derricks here, and then down through the steel jacketed structure in the middle here, these are all wells. So that's your sort of well bores. So when you look at an offshore platform, you can see, I see a bunch of pipes close together here. This is the well bay, and you can see there's no wells over here. This is some substructure stuff, and this is where the living accommodations are. So again, from a worker safety point of view, keep where you sleep away from the hydrocarbon. That's kind of a good rule of thumb. So this is a steel jacketed structure. Then there's also satellite platforms. So a satellite platform. So this is the same platform here. This is in Australia. So you can see. Well, here's a good zoom in of it. It's a single conductor, and then on the sides of it, these are wells, and this is the well bay where the wellheads are, but there's no accommodations. There's no place to sleep, and there's no gas and oil processing on here. It's just a place where you can drill the wells, and then there's pipelines that run from the satellite platform back to the main platform, the processing platform for fluid processing. And you can have, in some instances, when they're close together, these are bridge links. So bridge linked platform. It's actually a satellite of this, but you can actually walk to it because you put the bridge in because it's not very far away. Otherwise, you got to fly there or take the boat. Another type of production platform, gravity-based structure, or GBS, or sometimes called CGS, but called GBS. So this is so it's called gravity-based structure, or CGS for concrete gravity structure. So basically, and there's been quite a few of these made. These are all active, or a couple have been abandoned, but and what they are, this is Troll, the Troll platform in the North Sea, is a gas storage platform. So it's concrete that's slip formed up, and in cold water environments. So this is Norway, and this is Hibernia in just offshore Canada. This large concrete structure resists ice, so it can resist ice loads. This is a gravity-based structure in Australia, and its primary purpose, the gravity base, I don't think it's in these diagrams, but is for oil storage. You can use the concrete's hollow, and it's oil storage. Then on production platforms, one of the key things or decisions that have to be made in the design is rig versus no rig. So drilling rig or no drilling rig. So on this is the top sides. The telltale sign, of course, is the drilling derricks. So same as if you're driving around on shore and you see a drilling derrick up in the air, you know there's action going on there. Well, same thing on offshore platforms. You have drilling derrick, and then you'll have mud and drilling utilities. So you need to be able to handle the mud when it's coming back, treat it, condition the mud, and then also, it's not on the schematic, but also you have to handle all kinds of tubulars and completion equipment to drill the wells. So again, this is Hibernia again. You see there's two rigs here, two drilling derricks, and they're both over a shaft. And so the wells will be drilled through those shafts down to the reservoir. And here's a steel jacketed structure with a drilling derrick on it. These platforms on the bottom row have no rigs on them. They're production platforms, but they don't have the drilling rig. Reason being would be in your development plan, you might have pre-drilled the wells and you don't plan to drill any more wells. Then you don't need to put a drilling rig on the platform. Or you're doing a lot of workover activities, then you need the rig or something like that. So here's a lift boat. So this is a boat that actually has legs and just jacks up. And then this is putting a coiled tubing unit on this satellite platform. This is a production platform, and here's a jack-up drilling rig. We'll talk about that in the upcoming slide. And it just positions itself next to the production platform, and then the drilling derrick skids out over the well bay. So that and then drills from there. So then this platform doesn't need to have any drilling systems. They're all contained on the mobile units. This platform is in the Netherlands, and it doesn't have a rig on it. It's got well bays on either side. This is a snubbing unit that was built up on the top deck to do abandonments of some wells. So anyway, so that's when you look at an offshore platform, it doesn't have to have these derricks on it to be production, but that's just the drilling part. How are we doing for time? Well, we're getting close. Okay, that's okay. I'll go through this a little bit at speed. Drilling rig types. So, and for some reason this thing was reversed. So, drilling barge. So you have the land base, and then we have drilling barge, 5 to 50 meters. It's like a barge with a land rig on it. Then you have a jack-up rig, which operates. It says 150 meters. That's pretty deep. So it has legs and it jacks them down. I'll show you that in a sec. Then semi-submersible, a bit deeper, and then a drill ship, usually a dual derrick drill ship, for deep water. So you may have seen these things when you're out and about. Here's a drilling derrick, and then here's all the drilling systems and pipe racks and that sort of stuff. And then same thing. Here's a bit more of a modular unit. This is I think this is in US. This is in the Netherlands, and this one's also in the Netherlands. Again, locations are paved onshore there. So platform-based drilling rigs, we just talked about that. Again, drilling module, drilling support module. And here you see the wells going down in the well bay. And again, your accommodations is over by the helipad. This is Hebron, Exxon platform. Here's the accommodations module with the helipad on it. And you can see the lifeboats are here. Drilling's down through the shaft, fluid processing, and flare boom on that side. Again, to keep things separate. And a modern driller's chair is a lot of automation in the offshore drilling. Jackup, how does that work? So jackup drilling rig floats and it has its legs jacked up. Then it comes in close to where it needs to drill, and it jacks down just like a farm jack. Jacks down the legs and pre-spuds, and then extends its derrick and then drills. So these pictures are from the Northwest Shelf of Australia. So you see the rig is being towed in. Again, these legs are jacked up. It's like a big triangle. So these are 3 legs that are jacked up. It's coming in close to this production platform, as you can see here. So when it gets in close alongside the platform, it'll jack down its legs and then take on a bunch of water and preload to make sure that it doesn't punch through the seafloor. Then it'll get rid of the water and jack itself up. And so this picture is taken from the production platform, looking at the drilling rig, and it's going to skid out over this right here. So and then it skids out over the where the wells are to do the drilling. So that's a jack up drilling rig. This was about I think 50-60 meters of water, something like that. But you can put a jack up in 100 meters of water. Again, it depends on met ocean conditions. The water is shallower offshore Newfoundland, but it's a lot rougher. So jackups are struggling there. Light intervention vessel. That is that's a boat that's got basically a hole in the middle of it, a moon pool, and it'll come over a subsea well, and it'll run wireline or coil tubing down through the middle of the boat into the subsea tree. And you see there's a subsea stack, a subsea controller, and then the ROV, remote operated vehicle, will open and close valves, actuate things. So that's like a service rig or a wireline unit onshore. Offshore, you can do it with on a platform. You can use a very similar unit. Subsea, well, it's a light intervention vessel. Mobile offshore drilling unit. So this one is a semi-submersible, and so you can see it's moving to location. This is a prospector rig. So you can see it's deballasted, so the pontoons are up out of the water, and it's actually motoring to its next location. Same as the Transocean Barents here is doing the same thing. And like, this is not a bad place to work. Like, there's no reason why you can't work on these things. It's they need people. They need and they need petroleum engineers. This rig actually is one that my wife has supplied the temperature gauges for the mud system for this rig in Norway. So pretty proud of her on that. And so you have the drilling derrick here, and then in the middle of the rig, this is the moon pool, and so it's opening in the middle of the rig, and then this is the drilling riser going down to the subsea tree. So this is a drilling a drill ship. So you have a riser going down to the BOP stack, lower marine, just BOP stack on the wellhead. So this is a lower marine riser package. It basically connects the riser to the BOP stack, and the riser is just a big piece of pipe so that you can run your drill pipe through. And as the waves go up and down, these shocks compensate for the heave, so that you kind of stay in one. The pipe stays in one position. I think this is the last topic I have, which is good because not much time left. Christmas trees. For me, so a lot of people know what this is. I mean, it's a pump jack, and here's the well, and here's a schematic, simple schematic. So again, this is a horse's head. This is the polish rod. This is your Christmas tree, because the stuffing box is stopping well pressure from coming up this way, but going to the flow line, and your annulus goes through this vent line down the flow line. Looking at a gas well, so this is a gas well from the Netherlands. What does it do? It is a collection of valves at the top of the well that controls the flow. You open it, it flows harder. You close it, it flows less. So that is a Christmas tree. This one over here is for a bit of higher rate gas. It's a uniblock construction with a bit of a different bend radius, but it's the same thing. And you see there's actually a pneumatic cylinder on there for control. So, and again, an operator or an engineer, field engineer, would open and close these valves as needed. The lower row is on a platform, so still dry trees. These Christmas trees are still, you see some of the hand wheels here. They're very similar to this, but the well bay, again, it's offshore, spaces at a premium. They're only, say, a meter and a half apart from each other. So each one of these is a well. But and there's a bit more automation on here with pneumatics and hydraulics, so you can control it from the control room in the accommodations module. Just makes it safer. So very similar. So if you folks are working in Alberta, you have a work term, first job, and you're working on land on these dry trees, you already know what this does. It's the same. And so whether you're working here, you're controlling the flow in or out of the well using the Christmas tree. When you look at wet trees, subsea, they look really different. So you can see these two guys stand here. This is in the fabrication shop, or here. I think it's the Henry Goodrich. These guys are getting ready to deploy this Christmas tree, and to deploy it, they put it down the moon pool in the center of the rig. It's a lot bigger than your stuffing box on your pump jack, but the principle is the same. And the reason it's a lot bigger or different shaped is because subsea, you don't have a human go operate the valves. You've got a robot. You've got this ROV that has to actuate the valves. So, from a petroleum engineering point of view, what's needed? Someone to make these things, someone to inspect these things, someone to run these things, someone to run the ROV, someone to design the ROV. There's so many different things that's involved in this whole thing. Don't underestimate the value of learning that stuff onshore. So, and I think we're just about out of time. Canada's offshore. I think we're going to have to wrap it up. Maybe this is going to be a good session for another time. I'll just flip ahead. Well, I'll just go through this quickly. I just in 2 minutes. St. John's, 350 kilometers offshore. There's a few projects going on out here. Got Hibernia platform, again, drive trees. Hebron, that's also ExxonMobil, another platform. Sonova's just put the West White Rose platform in place. But this is in effect, a satellite platform because the production fluids are all processed over on the FPSO, floating production, storage, and offloading vessel, FPSO, C-Rose. That goes back there. And Suncor, there's the FPSO, Terra Nova. So again, subsea wells, module. And then, so this is all about 100-meter water depth. This is going off the continental shelf. And then over here at Bay du Nord, which is Equinor and BP are talking in planning to develop that. It's around 1,000, 1,300-meter water depth. So that's deep water subsea. So we got subsea and platform in offshore Canada. Hibernia platform, again, the GBS is built, the topsides is built, they're put together, and then and floated out, and you've got a facility that I think went out 30 years ago and probably going to be there for more than another 30. FPSOs, so this is Terra Nova. Again, it's got subsea wells in excavated drill centers so that icebergs can't hit the Christmas trees and damage them. So they just float over top. If icebergs do come down in the field, the FPSO has a turret where all these risers come up. It rotates around the risers, but if it has to, it can disconnect. So it can drop this spider boy down at depth and then sail away so that people are out of harm's way of the icebergs. And then this is Cenovus's, they got the C-Rose FPSO, same sort of disconnectable turret, subsea development. Again, here you see two supply vessels trying to lasso iceberg and get it out of the way. Cenovus just did a GBS at the top sides, and they've got a new platform over here. Hebron, another GBS platform. Here you see the platform being constructed and the GBS being built just over there. So, conclusion. There are lots of places to work as a petroleum engineer. Onshore has lots of transferable skills to offshore. Offshore petroleum engineering is fun. I find it fun. Onshore is fun. Offshore is fun. Questions? Next week, next Wednesday evening. Please register for office hours, and we'll talk some more about this. I know I went through a bunch of stuff there fast. There's some questions here. I've got to. We'll work on those, and let's talk about them next Wednesday if you're available. And this is the Hercules rig, which Suncor is currently going to bring back to offshore Newfoundland for next year. Office hours. Here's the QR code. Scan the code, and then we'll see you next week, next Wednesday at 9 o'clock Newfoundland time, 8:30 in Nova Scotia, 5:30 Mountain. So thanks everybody for your time. Sorry to go over just a little bit. And big shout out to Mohammed for taking the initiative here. But yeah, thanks. Hope you enjoyed it, and hope to see you on Wednesday. Please sign up and please get some more questions in, because that makes this all better. Okay. Thank you very much. And that's it for me because we're out of time. Good night, everybody.